All right, welcome back, everybody. I apologize, my video is not working, so you're going to see probably all of the videos this week not having any video of me. Today we're going to be talking about section 3.3. This is going to be our first day on it. We're going to spend a couple of days. So we're talking about properties of logarithms. Our objective today is that you're going to be able to expand logarithmic functions using the properties of logarithms. So before we get going, let's just recall a couple of facts. Remember, a couple different things here. So when I have two expressions that both have exponents and they have the same base, we're able to combine those together by adding the bases together, right? Now, this is true even though this is a multiplying problem. So x to the fourth times x to the sixth, we actually add the exponents and we end up with x to the 10th. Right? Okay, that's something that's important. When we multiply, we really add. Now, coming over here to this division problem. Now, over here, we are dividing two exponents. So, what we should recall is that we take the top exponent and we subtract the bottom exponent, and that gives us x to the 7th. So, when we multiply, we add, and when we divide, we subtract. Now, down here in these next two blurbs, we actually summarize that. When the bases are the same and you are multiplying, add the exponents. And when the bases are the same and you are dividing, you subtract the exponents. Now, the skill we're going to be talking about today is very important for you, so we're going to start kind of small and build it up as we go, but this is going to be one you really want to get your hands on. Expanding and condensing logarithms, okay? Today we're going to focus primarily on actually expanding them, and then tomorrow we're going to spend some time condensing them. This is what I mean by expanding. When I have a logarithm of two things that are being multiplied together, a times c, we are able to break those up into two logarithms that are being added together, right? So instead of the multiplying symbol, we introduce an addition symbol. And same with dividing. So if I have the logarithm of a quotient or something that's being divided, that's really the top one minus the bottom one. So here's our first one, minus a logarithm base b, all the bases stay the same, of the bottom. So let's get our hands dirty here a little bit. So looking at this first problem, it says log base 2 of xy. Right away, you want to look at this piece and say, well, it's being multiplied. Well, if it's being multiplied, you can break it up using addition. So we can rewrite this as log base 2 of x. Since it's multiplication, we add, and then this will be log base 2 of y. We broke it up into its two parts. There's no longer condensed. We're done. Looking at the second problem, here we see we have something that is being divided. So division means subtraction. So we can rewrite this as log base 4, that part's never going to change, of the top, which is x, minus the bottom. So again, log base 4 of the bottom, which in this case is y. So that's going to sit over here, and we'll be done. Number 3 starts to get a little bit unique because it starts to combine multiple different things. Up top, we can see a and b are hooked together using multiplication. So the way we want to write this, now, again, we don't see a base here. So if there's no base, it's just our normal log function. We assume base 10, but we don't need to write it. So we can say this is just the log of a. Now I'm going to break it down kind of top to bottom. So I'm going to deal with this first. So log of a plus the log of b, and then since the c is on the bottom, that one's going to get the subtraction, minus log c. And again, if you wanted to write the 10s in here, you wouldn't be wrong because those are all assumed to be base 10 if we don't see one over here. Looking at our last problem here, now this isn't 2 times 5, this is just 25. So I can rewrite this as log base 5 of 25. Since we are dividing, we want to subtract over the log base 5 of x. Now, something unique on this problem that we're seeing for the first time. Both of these two things are numbers. We have a base and we have a number. And when we do that, we can actually sit there and evaluate this. So remember, switching this to exponential form, log base 5 of 25 would mean 5 to what power is equal to 25? And of course, with a little bit of work, we figure out that x equals 2. So what that means is that this whole expression just simply equals 2. So the better way to write this would be 2 minus log base 5 of x. That would be our final answer. And it's important to realize we couldn't do that here because we had a variable still. Had a variable, 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 had a variable. But if we ever get to a spot where we don't have a variable, it's something we at least need to look at. Last rule we're going to discuss today is what we call the power rule. Now, the power rule is something that's very important and it often gets used a lot. It's sometimes easiest to see when we actually look at an example, so let's just hop right into it. When we are trying to take the log of a number, and that number, that expression, has an exponent on there, the way that you deal with that exponent is by pulling it down in front of the whole thing and multiplying your log by it. And what I mean by that is that this can be rewritten as 2, right? There's that exponent getting pulled down in front, times log base 3 of x, right? So essentially, any exponents we have, we can pull down from the top, like you are seeing right here, pull it down from the top and put it in front and multiply it by whatever it was kind of attached to. So same thing's happening up here. This m has an exponent, so the exponent gets pulled down in front, and now it's being multiplied by that whole expression. This is what we call the power rule. Now, it does say here, you cannot leave powers in the final answer when you are expanding. Okay, so we're always going to have to use this power rule if possible. This is just a quick summary of your properties of logarithms. So product and the quotient were the two we were using before. And then the power property is the newest one we're introducing. So let's look at a few problems together to get the wheels kind of turning, and then we'll get you going on your homework. Now, right off the bat, this is something we want to get familiar with. Whenever you see a square root, remember you can write this as x to the 1/2 power. So I can really rewrite this and say that this is just log, well, essentially if there's no base, you could just write 10 if you wanted, of x to the 1/2 power. Now, since this piece has an exponent, that exponent needs to be pulled down in front. So we can rewrite this as 1/2 log base 10 of x, and that will be our final answer. The exponent gets pulled down in front. Here's another one. This one has a little bit more going on. So first off, we see our exponent. So we're going to pull that in front. So this is going to be 4 times log base 2 of 8x. Now, when we look at this, this is kind of the term we always look at. And if we notice, well, hey, this is actually being multiplied, then we should break that up. So breaking that up, we're going to be able to break up log base 2 of 8x into log base 2 of 8, since it's multiplying we add, plus log base 2 of x. And essentially, the 4 would even distribute into both of these. So 4 times log base 2 of 8 plus 4 times log base 2 of x. Now, and just to make things a little bit more difficult, you've been given a problem where both of these are numbers. So we should really rewrite that and think about it. So rewriting that, I would say 2 to the x power is equal to 8. Sometimes there's an easy answer to this, sometimes there's not. But in this case, we know that 2 to the 3rd power is equal to 8. So this whole expression equals 3. So this would be 4 times 3 plus 4 times log base 2 of x. And this, of course, becomes 12 plus 4 times log base 2 of x. It is important to realize that we can't add the 12 and the 4 right here. That 4 needs to be multiplied before it could be combined, which will leave this as our final answer. Right? So there's a lot of layers and intricacies that we can kind of see and play with as we go. Looking at our next problem right here. So again, we're trying to expand this. So we're going to pull the exponent down in front, and then we have a division, so we're going to be doing some subtraction. So coming over here, we're going to have the 2. That's going to sit in front of everything. This will be log base 6 of x. Since it is division here, we are going to subtract, so there's the minus, log base 6 of the bottom, which is y. Now the 2 does need to get distributed through, so it's going to sit in front of each of those, so this will be 2 log base 6 of x minus 2 log base 6 of y. And that will be our final answer. Looking at our next one, first thing I would tell you to do is rewrite it using an exponent instead of the square root there. So I could rewrite this as x y to the 1/2. Now it's just y to the 1/2, so we can't pull that down right now because that would go to both of them if we did. So we don't want that, so we're going to wait to pull that down. So we're going to simply rewrite it. Since these are being multiplied, we're going to add. So I'm going to have log base 2 of x plus log base 2 of y to the 1/2 power. Now, since there is still a power, we need to pull that down, right? This is what I mean when I say that the 1/2 didn't go to both. It only goes to the y, which is why it's only going to sit in front of the y. So I will have log base 2 of x plus 1/2, because my exponent got pulled down, times log base 2 of y. Looking at another problem over here, this one gets even more complicated. So first I'm going to sit there and just do some rewriting here. So this is obviously the same thing as log base 2. We're just going to leave it as x squared there, y, and then z, or the cubed root of z, could really be written as z to the 1/3 power. Now, since none of these have an exponent that goes to all of them that's consistent, we can't pull anything down in front. We need to break it up instead right now. So I'm going to have log base 2 of x squared. That was the top. Now, since we're dividing, we need to subtract. So we're going to say minus log base 2 of y. And then this is kind of a part that's new and unique. Since z is still on the bottom, that still needs to be subtracted. So log base 2 of z to the 1/3, right? It's kind of important to see this. Notice how everything on the bottom has a subtraction symbol in front of it. Now, the last part is just to pull down any exponent. So we see an exponent. We're going to pull that down. Exponent, pull that down. So my final answer here will be 2 times log base 2 of x minus log base 2 of y minus 1/3 log base 2 of z, making this my final answer. Looks like we have a couple more problems here. We're going to pick up the pace a little bit. So up top we can see this is hooked on by multiplication here and by multiplication here. So when I rewrite this, x, or the square root of x, will be x to the 1/2. So this will be log. Since we don't have a base, we don't need to write one. We can just say log. So log of 10 plus log of x to the 1/2. Since those are on top, they're both positive. Now we're getting to the bottom, so these are both going to be subtractions. So I'm going to have log of y minus log of z squared. Pull down your exponents if you have any. So this would be log of 10 plus 1/2 log of x minus log of y minus, again, my exponent's going to come down. Not that. 2 log of z, making this my final answer. Looking at the next one, again, x to, or the cubed root of x can be rewritten as x to the 1/3 power. So I'm going to have log base 2 of x to the 1/3. Since that's on top, that's the positive one, minus the bottom one, since we are dividing. So I'm going to have log base 2 of y. The 1/3 needs to move down, so my final answer here will be 1/3 log base 2 of x minus log base 2 of y. Looks like we've got 2 more problems, so here we go. Again, this is 27f, that's being multiplied. we could rewrite this as h to the 1/3 power. Those two are, of course, being multiplied together, but they are on the bottom, so we will be subtracting them. So, looking at this, we can start by rewriting this as log base 3 of 27, right? That's on top, so is the f, so we're going to keep the positive. We'll have log base 3 of f. Now we're going to the bottom, so now we're going to switch to subtraction. Log base 3 of g, and then minus log base 3 of h to the 1/3 power. Any exponents need to come down at this point, so this 1/3 is going to need to come down in front, but that's really the only one. So I'm going to have log base 3 of 27 plus log base 3 of f minus log base 3 of g minus 1/3 log base 3 of h. Now at this point we've made a lot of progress. One thing that we do need to notice is that these are both numbers. So since those are both numbers, we should try to evaluate them. So basically what we're saying is 3 to some power is equal to 27. Well, with hopefully a little bit of work and knowing something about our powers, we know that 27 is just 3 to the 3rd power. So I get 3 to the x is equal to 3 to the 3rd, which means, of course, that x equals 3. So this whole expression equals 3, and everything else should just drop down into place. Making this our final answer. Last problem, here we go. So coming over here, we have a lot of stuff being multiplied together. Z, the square root of z will be z to the 1/2, of course. So rewriting this, we'll have log base 2 of 100. Again, we see two numbers there, so we're going to think about that in a minute. And then since we're multiplying, we're going to add. So this will be log base 2 of x to the 3rd plus log base 2 of y plus log base 2 of z to the 1/2. Pull down any powers that you see. So this will be coming down. This will be coming down. While we're here, let's also evaluate this right here. So again, we would say 2 to the x power is equal to 100. Now, thinking about this, I don't know what number, right? Because 100 cannot be written as a base of 2, which means there really is no power in which 2 is going to get there. And you could even do a little bit of quick work on a calculator here if you weren't sure of that. So I would just come over here, 2 to the, let's just try 5th. Well, that's 32, so let's go bigger. 2 to the 6th. Up 2 to the 7th. Notice how I jumped from 64 to 128. I jumped over 100, so we don't have a number that makes that work. It means we're dealing with the decimal, which means we'll leave this exactly like we see it. Pulling down the 3, we're going to have 3 log base 2 of x plus log base 2 of y. And then finally, if I pull down the 1/2, I'm going to have plus 1/2 log base 2 of z. Making this my final answer. Thanks for watching, everybody. If you have any questions, please do not hesitate to reach out and ask. Thanks.